My name is Alan Pickering, and this is my latest hot air engine, built in 2018 and was only finished last week. It was inspired by a video of an animated engine, a YOLK engine, on YouTube. This is the YOLK mechanism. It appears it doesn't scale very well. I don't think you can scale nature too well, but I'll run it slowly so you can see the beauty of the mechanism. Its claim to fame is that the conrods are almost parallel motion, and so put no sideways thrust on the pistons, and consequently lack of wear. It's not very well balanced. In fact, it's not balanced at all. I put an extra balance weight here on the flywheel, and you've got the big end yoke as well on the other side. Friction is a big problem with all these engines. I've put 9 bearings in this. 3 of them are ball races. This is one. This is the other, the biggest, and this is the big end. All the others are needle races, which are in the mechanisms of the motion. I made it water cooled because I wanted to run it as a show engine for a decent length of time. You mustn't run it without water because there are gaskets and you don't want them to be destroyed. There's one, for example, a rubber gasket, big one. This is my nameplate, if it shows. If I can keep this still, I'll try and get the thing going. Let's have a look. There we go, made it. Turn the pressure up a little. This is a heat shield, this brass dome on top, just to keep the heat where it's wanted and not heating everything else. It warms up fairly quickly. Still thinking about it. Yes, there we go. Turn the gas down a bit. That's probably doing about 1 rev per second. Quite hypnotic. Just walking around the engine. Let me turn it up a little bit. There we go. Quite a compact little design. I've not seen anything like it before. As I said, it was built as a show engine for educational purposes only. It doesn't go very fast, but has reasonable power. There's such a lot of heavy moving parts and a big flywheel, this limits its top speed probably to about 100-ish RPM. Make it go a little bit more go. This is a cooling tower. This here is a little breather pipe which goes right down to the end of this horizontal section here, which is holding water, and there would be airlocks in there as you fill it up. So this breather pipe fills it up fairly quickly, or allows the air to escape. To make sure that it does all work properly, there's another little valve here. I can show it. And this is to get rid of airlocks. And if I open it, a drop of water should come out. There it is. The piston came out of the scrap box, 1.5 inches diameter, a lawnmower or an outboard engine or something like this. The stroke is 2.5 inches. A stainless steel cylinder, which was a lump of stainless I had and machined out. Turn this down, making a bit too much noise. Turn it till it nearly goes out. There we are. We're quite low now. And that's quite happy. Ticking away lovely. I've put magnets underneath this burner. You can see them. 2 neodyne magnets. Otherwise, the hosepipe pulls it all over the place. Now this looks an easy engine to build, but it's not. For a start off, it's made of structural steel, which is meant to hold skyscrapers up, not as a frame for a hot air engine, a precision hot air engine. It's got to be welded and it's got to be kept square. Well, it's not square in the first place, so you've got to do your best using an angle grinder or whatever you've got to get it square. Weld it square and put it right when you've welded it. If you don't get this frame square in every direction, you're going to have massive problems lining everything up. It doesn't work. There's so many main bearings and needle bearings. They need 100% right alignment. It's a nightmare. It took me a couple of months to make and a week to get going due to alignment errors. There were only thous, but they stopped the engine. It's just about ticking over now. It'll go forever like this on no gas. One of the main problems with it is the cylinder head, sealing the cylinder head. You've got this coffee jar, and I've got a spare one here which I'll show you. You can just hold the camera still for a while I just go up there and look on the top shelf. Oh, there it is. And this is what I used for the displacer cylinder. Now the coffee jar is the same size as the box section, so precision drilling is the order of the day. All these holes around here a 2BA, they've got to be precision drilled. You've got a 3.5 inch hole to go through the middle of this box section, which is 4 inch, and you've got to seal with a watertight seal this stainless coffee jar into this thick box section. Well, I made it a good fit and it was smashing, but when it comes to silver soldering it in, it's like silver soldering the top of a biscuit tin. It pops and bangs and jumps all over the place, and it was very difficult to do. I succeeded in the end, 90% success rate, and the rest was taken up with Loctite and the gasket, and it's 100% sealed, no problem. There's a little valve under here, under the there it is, under the main cylinder. This is for draining the power cylinder, because when you put oil in, or WD-40, whatever you like, in it goes, finishes up in the bottom, and after a while it's full up, so that just drains it, saves you having to take the piston out. Altogether, I'm very pleased with this little engine. It's compact, it keeps going, doesn't use a lot of gas, and it's slow enough for people to admire. I mean, at present now it's running quickly. I could turn it down a little bit. Silent as night. The only expense in the whole thing was the flywheel casting, which I got off eBay for £30. It's an 8-inch flywheel. No, it isn't, it's a 9-inch flywheel. And there we have it. Altogether, a very cheap engine to build, but you need the patience of Job. I hope you've enjoyed this little video taken in my workshop. You'll see other videos, one of my whole workshop. You can also see things that I've done on the pages of Model Engineering, and this will appear on the front cover of Model Engineer like my other hot air engines. And this is basically a view of the rest of the workshop. Very quickly. And there we have it, folks. That's my final effort. A very pleasant little engine. This is called an inverted Ross-Yoke engine, water cooled. Normally Ross-Yoke engines are the other way up, with the cylinders up in the air above the flywheel. This makes it difficult to fire, and this setup is a more compact layout in my opinion. This is Alan Pickering signing off, and I hope you enjoyed my little video. If so, please look at my other hot air engine videos on YouTube.